Okay, folks, what we want to do is we want to talk a little bit about the law of cosines. The law of cosines. So if you notice in this diagram here, I have my triangle, okay, and I have side vertex A, vertex B. I have little b, and I have little a. Now, in this particular spot, I'm measuring A, okay, so I'm measuring A right here, and down here at the bottom, just to kind of make it a little bit easier to see, I'm measuring B, and I'm going to put that right there. So B is 15.66. And then over here on this side opposite this angle, I'm going to call it P, and 9.95 centimeters. The only angle that I'm going to emphasize is this angle P at the bottom. And I'm going to use my measurement here. In this case, in this instance, it's 36.34 degrees. So if you notice, I'm going to take B and move it slightly. When I take B, vertex B or angle B, and move it slightly, the angle changes. The only thing that's not changing is side B. Okay, that makes sense. Of course, I could change side B by just moving another vertex here. Okay, so those are my values, and we want to talk about how this is related to the law of cosines. So again, how is this related to the law of cosines? The law of cosines says that if I have an angle, of course here's P, my angle, and then I have a side opposite it, okay, there is a relationship, and that relationship I have described here below. So in the first case, I have P squared, that is this side squared, okay, and then on another expression I have down at the bottom, I have A squared, that side squared, plus B squared, and then I'm going to subtract from it twice their product, so twice A times B, okay, twice their product, times the cosine of this angle, okay. Now when I do that, I want to compare the two values. So if you put all of these numbers in your calculator, you would come up with, if you were squaring P, the 10.39, you would get this number, okay. Does that make sense? If I try to lower this down to about 10, that's about 100. So that does make sense. Now, I'm going to also compute this other part. And notice when I compute the other part, I get the same value as the square of P. So that is very, very interesting. Okay, and that works for no matter which way I move this triangle around. If you notice, the numbers at the bottom still are remaining the same. Okay, that is very, very interesting. Also, if you notice, it doesn't matter what vertex I move. Okay. Okay. Now, what if I move this vertex? Okay, it's going to change the side of P, so that value is going to not change. That value is going to change in this case. All right, so that's the gist of how the triangle is set up, what the law of sines formula is about, and the fact that it really does work. Let's explore some more. Now, someone's going to ask, how can I prove the law of sines? Well, we could use what's called analytical algebra, coordinate algebra, and place our triangle on the coordinate plane with the vertex at 0, 0, and with the vertex B sitting at this location right here on the x-axis. Okay, if we did that, then we understand that this side length, C, okay, is little c across from angle C. And if we do a little algebra, we could discover for ourselves how this distance from point C all the way over to point B, or the length of A, can be described algebraically. So down here to the side, notice we have A is equal to the distance between those two locations. I square, and then I replace the x and I replace the y with their values using the two triangles here in right triangle trigonometry. Again, I do the algebra in this step. I also noticed that I could factor out a b squared, and we know this identity, sine squared plus cosine squared is equal to 1. And then lo and behold, here at the bottom, I have a version of the law of cosines, or I have one orientation of the law of cosines. Now, if you studied this before, you realize you could turn that triangle different ways, and then you could get 3 different formulas for the law of cosines. I have found it's easier just to know one version and just apply it in the different cases. That way you don't get confused with the A, B, and the C. Again, I would just simply look at our triangle we started with here, okay? And notice we have P, then we have this angle P, we have the two sides A and B. So let me verbalize the law of cosines. Given two sides and an included angle, we know that the square of the third side is equal to the sum of the squares of the other two sides, that's right here, minus twice their product times the cosine of the included angle. So there you have it, a verbal representation of how the law of cosines can be expressed. I showed you it numerically, showed you it algebraically, I showed you it geometrically, and so hopefully this helps you appreciate and be able to use and apply the law of cosines. And try to remember, as opposed to the law of sines, the law of cosines enables us to solve a triangle when we don't have a pair. I hope that explanation helped you.